Welcome to Math 10C. We are in Chapter 7, the very last lesson, 7.6, where we look at properties of systems of linear equations. This is a fairly quick lesson where we're going to look at the kind of solutions we can get from a linear system. So let's begin by looking at this table where we'll look at three possible situations. As you look at this first set of equations, sorry, jumped away a little bit there. For this first equation that we have right here, it's in slope-intercept form, so I can see that my slope is equal to 3 and my y-intercept is equal to 7. And then as I look at the second equation, my slope is negative 2 and my y-intercept is negative 3. So the graphs are given to us here already, where the first graph has this positive slope, and you should use a ruler. I didn't, just to highlight that. The second graph has the negative slope, and we see it there-ish. And the solution, as we know, is the point where the two graphs intersect, which I think is at about negative 2, 1. So the result that we have in this situation is what we've seen most frequently so far, that we have one solution. Now, what is it from the equations that tells us there's going to be only one solution? Well, as we look at the slopes and the y-intercepts, we'll see that both of them are different. They have different slopes, they have different y-intercepts. The y-intercepts aren't a big deal in this situation. The key piece of information is that if we have a linear system where the two equations have different slopes, we know that we are always going to get one solution. Let's look at the next system. In the first equation, we can see that our slope is 2, y-intercept negative 3. The second equation, slope is 2, y-intercept positive 4. And again, as we summarize what's the same and what's different, we can see that we have the same slope, different y-intercepts. If this happens, then we end up with two lines that are parallel. So here's that first line, here's that second line. They're parallel since they have the same slope. Different y-intercepts means they don't cross anywhere, and so the result is that we have 0 solutions. This time, we want to look at both the fact that slopes are the same and y-intercepts are different. That results in 0 solutions. One final situation. As we look at this first equation, we can see that our slope is 2, our y-intercept is 4. The second equation is a little bit sneaky because it's not actually in slope-intercept form. So I need to do some rearranging here. So I'm going to add 2 on both sides of my equation to give me x plus 2 is equal to, and I'm going to write that 0.5 as a 1/2 y, because then I can see to isolate my y, I need to multiply both sides of the equation by 2. When I do that, and I distribute this 2 into the brackets on the left, I get 2x plus 4 is equal to y. There you go, a little bonus message from Miss Codd. Y. So there's our equation in slope-intercept form, and we can see our slope is 2, our y-intercept is 4, and so as we kind of summarize here, we see that the slopes are the same and the y-intercepts are the same. Same slope, same y-intercept. So my first graph is right along this line here, and my second graph overlaps it exactly. So where do these two graphs intersect? They intersect everywhere on the line, which gives us an infinite number of solutions. Every point on one line is also on the other line, so we get infinite solutions. Here's a summary. When we want to determine how many solutions a system of equations has, without going through the steps of trying to solve it, we will start by writing both equations in slope-intercept form. Once we do that, if our result is that our slopes are different, that means that we will have one solution. If we find out that our slopes are the same, then there are two possibilities. We need to look at the y-intercepts to find out how many solutions we might have. If our y-intercepts are different, then we have zero solutions because our lines are parallel. And if our y-intercepts are the same, then we have an infinite number of solutions. And in this situation, we say that our lines coincide. Sometimes we say that they're coincidental. I don't know if I spelled that right, but you can check. There we go. That's pretty much the lesson. So you can look ahead to the next page, and you'll see some check your understanding questions to complete here and on the following page. So why don't you pause the video now and work through these questions. When you're ready, restart the video, and I'll show you my answers to all of the check your understanding questions. Question number 1. Our strategy is to rewrite our equation in slope-intercept form. So that's what I've done here. I see my slope is negative 2/3, y-intercept negative 5/3. Rearranging the second equation, I discover that I have same slope, different y-intercepts. So they're close, but notice one was a negative y-intercept, one was a positive y-intercept. Wait a minute. I've made a mistake, haven't I? As we look at our second equation here, where I did 5 divided by negative 3, I lost track of my negative sign, so this is actually subtraction. They do have the same slope and the same y-intercept, which means our two lines are coincidental. There's an infinite number of solutions. Question number 2, rearrange the equations into slope-intercept form. When I compare the slopes, I see the slopes are different, and the result, there's going to be one solution to the system of linear equations. Number 3, rearrange the equation. I have a slope and y-intercept. Rearrange the equation. I see the same slope, different y-intercept, which means my lines are parallel. There's no solution to the system of linear equations. For these next questions, I'm not going to go over answers, but I will just give you the reminder that if we have exactly one solution, that means we have different slopes. So as long as you had two equations with different slopes, excellent. Number 5, infinite solution means same slope and same y-intercept. And for no solution, you will have the same slope, but different y-intercepts. Final question in this lesson is just looking at applications. And so as we look at this situation, here's what will happen. Let me just review the information we're given in the question here. So the question starts, there we go, starts about here. So we have two fields, and we have a total area of 1,800 square units, whatever units they used. And then we're told how it produces grain. So one produces grain at a rate of 2/3 of a bushel per square unit, and the other produces grain at the rate of 1/2 a bushel per square unit. So we're given two types of information here. We're given information about total area, and we're given information about how many bushels each area is going to produce. So here's what I did for creating the equations. We have those two types of information about the area of the field and information about the bushels produced. So that's going to lead us to two linear equations. Field 1, we don't know the area. So I can just choose a variable. I'm going to go with x, and I don't have to write a let statement because this table tells me that this is the area of field 1. Field 2, I'm just going to call y, and we know from the question that we had a total area of 1,800 square units, whatever those units are. Then with information about how many bushels are produced, well, suppose I had, for my first field, if it had an area of 10, then we would take that 10 and we would multiply it by 2/3 to find out how many bushels were produced, which would be 20/3 of a bushel, which would be like 6 2/3 bushels. So what did we do? We took the area of the field and we multiplied it by how many bushels per unit area. It's helpful sometimes to think through with numbers, because then when we come to the variables, we recognize, oh, I'm just going to take 2/3 times the area of this field. And for field 2, it's 1/2 a bushel per square unit. So it'll be 1/2 times y. And then we have the total yield, which is 1,100 bushels, 1,100. So how would we solve the problem? We would create this system of linear equations and then go through and solve it. And I will leave the solution up to you. That is the end of this lesson. It'd be good for you to practice some questions. If you have a textbook, you can do one of these sets of questions. Or if you have the Check Your Understanding handout, you could do those questions. All right, have a good day.